All right, we're going to go ahead and get started. Hello and welcome. My name is Wes Rice. I'm the conference chair for QCon San Francisco and co-host of the InfoQ podcast. Today, we're starting the first of a new webinar series brought to you by the folks at InfoQ focused on software development. These are speakers from our community. Today, we're going to hear from Daniel Spoonhour. Everybody calls him Spoons. He's going to be talking on the topic of K8s and observability. Spoons is a former infra engineer at Google turned CTO, co-founder of Lightstep. He, along with his co-founder, Ben Siegelman, the creator of Dapper at Google, are some of the foremost thinkers when it comes to distributed tracing today. These are the guys with their co-authors who wrote the book on distributed tracing. Today on the InfoQ webinar series, he's going to be talking about observability, K8s, in a talk called Solving the Hidden Costs of Kubernetes with Observability. So a little bit of housekeeping before we jump in. Everybody's mics are muted by default, just to kind of keep a little bit of the background noise. There will be an opportunity for questions. We're scheduled for about an hour here. Content runs about 30, 35 minutes. So we'll have a good 25 minutes at the back end at the very least to be able to answer questions. So we're gonna hold those to the end. I will be monitoring them though. So if you look in your little dialog box, there is a hamburger menu there that if you expand that, you can ask questions there. I'll be monitoring those, grabbing those, and then towards the end of the talk, after Spoons is done, I'll kind of curate those and bring them to the surface. Continue asking them, and we'll, like I said, we'll still have some ample time for questions there at the end. This is, there will be an on-demand video of the webinar, so we'll communicate that afterwards on where exactly you can find it. Once again, thank you for joining this first pass with us with the webinar. Thank you for trusting us with your content and your education. And Spoons, I think I'm going to stop talking and turn it over to you, sir.
Awesome, thanks.
You bet.
Yeah, so I'm going to talk about the hidden costs of Kubernetes and how observability can help address those. As Wes said, my name is Spoons. I'm a CTO and a co-founder at Lightstep. Lightstep is simple observability for deep systems, and whether you're trying to address an outage in the middle of the night or just trying to see whether or not your latest deployment has broken anything, Lightstep can help you understand what's changed in your application and get things back on track quickly. As Wes said, I also helped write the book on distributed tracing. It's a great, I mean, I have a biased view, but a great resource. I think started from the beginning. What is distributed tracing? How do you instrument your application? How do you think about costs that are associated with distributed tracing? Walking through a bunch of use cases where you can get value from distributed tracing, and then finally thinking a bit about the future and where we're going from here. So check it out. Yeah, so Kubernetes, let's talk about that. Before we you maybe know this already, but Kubernetes is really just an abstraction, right? So it's a step along a long journey that we've been on together. You know, in the old days, it was about bare metal and you know, racking the servers, plugging them in, and things like that. We went a little bit higher up when we got to VMs. We didn't have to think about power cables anymore, but we're still managing a lot of the OS and things like that. From there, we got a little bit higher with containers, limiting kind of the surface area that we had to worry about. And now with Kubernetes, we've lifted that abstraction even higher, right? So there's fewer things that as an application developer, I need to worry about. Those could be things like lifecycle management, you know, restarting pods, things like that. It could be something around scaling, or even network management and, you know, managing ingresses or routes within your application. These are all benefits, right? Like I have to worry about less in some ways, but you know, it's not a silver bullet, right? That abstraction doesn't come for free. It doesn't magically make all the infrastructure easier to manage. There still is infrastructure under the hood there, right? It doesn't make it easy to understand the performance changes resulting from a deployment. It doesn't help you aggregate telemetry data necessarily without new tools. And it doesn't solve traditional monitoring questions, let alone, you know, the new unanticipated questions that come along with, you know, a microservice-based architecture. And I think kind of to understand why we have to step back a little bit and kind of look at the bigger picture. So in any software system, and really this goes for a whole bunch of other kinds of systems, not just software, but you have a feedback loop, right? On one side, you've got control. And you know, in a factory or a chemical process, that control might be something like, you know, how fast you're moving the production line or how fast you're adding reagent or something like that. In, you know, in the software world, in the Kubernetes world, we've got a lot of great tools to help understand or help control the way the application is behaving, right? These are things that let you affect change within the application. And while that's pretty awesome. The thing is that I think, we've seen a ton of great innovation and a lot of investment on that side of things. We haven't seen as much on the other half of the feedback loop, and that's the observation, the ability to observe and see what's happening. When we talk about observability, the term observability actually comes from control theory, where these two sort of opposing sides of the equation, control and observation, are really important. Control, your ability to affect change, and observability, your ability to understand what's happening. And we haven't seen, like I said, as much investment in the observability side of things, and that honestly I think can be a little bit scary, right? It's like having a gas pedal without a speedometer, right? So you can affect change, but you don't know what's happening. And this, I think, has consequences on a lot of different scales, right? So if you don't have the right kind of data to understand what's happening, you can't build an autoscaler, right? Because you don't have the inputs to actually drive that. And even if you go, way up to like thinking about, a new service or your overall application architecture, if you don't understand how the components interacting, you don't know how to make good choices about that. And this, I think, is really kind of at the crux of the problem with distributed systems in general. And that's really kind of embodied here. So, each team with Kubernetes got more control over their service. That's great, right? They can work more independently, but that control is now distributed across all of those teams, right? And each of those teams depends on lots of different services. So kind of in the picture here, you as an individual team or one of the teams in your organization might be at the very top of this pyramid here. So you can kind of think of this like your stack. But they ultimately depend on all of the performance of the services below them as well. So even though they can only control one piece of it, they're responsible for the performance all the way down. And that goes not just for services, but like infrastructure, managed services, anything that's part of your application. And this idea that you've created or experienced this disconnect between control and responsibility is sort of the textbook definition of stress, right? So I think this, if you're feeling it or if your teams are feeling it sort of viscerally, this is sort of, I think, an explanation for sort of what's going on. And the questions then is how can we offer more control and how can we offer them a better understanding of what's happening and give them the ability to take responsibility for what's happening in a way that's not so stressful. A big piece of that is going to be understanding costs, right? And these costs are going to vary across a bunch of different aspects. I'm going to kind of touch on 3 of them. So the first kind of category of costs that I think are exacerbated by a microservice architecture, by a move to Kubernetes, is around monitoring. So, first of all, logs were never cheap. And now if you're logging not just from your monolith, but from every service, you just exploded the number of logs that you're creating. That's going to result in some cost. And the other aspect of this is around metrics as well. Metrics are often priced around cardinality, whether you're buying from a vendor or thinking about the infrastructure that you're going to need to pay for to run your metric solution. Cardinality is the set of different, well, generally the set of different things in a set. When we're talking about monitoring, we're talking about the number of different tags and different combinations of tags, right? So each different metric you have, whether that's CPU or RAM or some queue size, that's going to contribute to cardinality. Each different host you have is going to contribute to cardinality. Each different region, each different version of your software, each different user segment, those things are all contributing. And it's not just a linear thing. These things are being multiplied together, right? So that's why you get this explosion, again, of the amount of data involved. And Kubernetes is really helping in a sense, right? Because it's making it easy to add more tags. And in fact, there's a lot of value in doing that, right? Understanding how the different aspects of your Kubernetes deployment are affecting performance. And usually when this comes up, it starts a discussion along the lines of, should we think about a different vendor? Maybe like this person is here. Maybe we should move to our own solution. Maybe we already have our own solution, but we're really feeling the pain of the cost. Maybe we should be monitoring less, right? And that can be really scary because that's just going to make identifying root causes even harder, right? And I think as you scale up, this is just going to get worse again as you're doing more deployments, as you're building out, across more regions, more teams, all these things really having multiplicative effects. A second area of cost is around understanding the dependencies between your services in your system. So it's easy to add new services, right? Just add a little bit of configuration and you can go. It's easy to add dependencies on external APIs, right? You just bring in that SDK and go. but the cost of microservices has always been high, right? Martin Fowler talked about sort of a tax, right, that you pay in terms of just the additional understanding, additional steps that everyone needs to take and be aware of. There's a little bit of a I don't want to call it a backlash exactly, but people are kind of thinking about some of the choices they've made around architecture. Kelsey Hightower's been arguing for monoliths. I think there's a right and a wrong way to do these things. I know Uber has been talking about macro services now. There's certainly a kind of history repeating itself in a lot of ways, but again, kind of the point is here, as you're building an application on a platform like Kubernetes, as you're giving your teams more independence, you're creating more dependencies between them at the same time. The third area of cost is really just thinking about the abstraction, right, that Kubernetes provides. The fact that that doesn't come for free, right? So, you still have to think about, well, now you have to run this whole other piece of infrastructure. You have to think about how to run storage systems on that piece of infrastructure. You have to think about, how are you building an application that's resilient to node upgrades, right? To failures below the Kubernetes abstraction, because there's still probably VMs or bare metal underneath there, right? And this is something that you can build, through building up a team with that kind of expertise and in trying to ingrain that in your sort of organizational, your institutional knowledge. But that's a cost you're paying, right? That's time spent that you could be doing something else. And of course, there's just more complexity here. There's more things to keep track of, right? So kind of three areas of cost. And I kind of want to think a little bit about how we can solve this problem. And maybe, not surprising where I'm coming from, observability is a big part of that. But again, like I was saying, I think there's really a complement to the benefits that Kubernetes are providing that we should think about observability and how that can kind of fill in a missing piece of the puzzle. What is observability? Maybe I should start with that, right? Well, at a high level, it's a process and a practice for understanding your system. So it's not like something that you can just go and get some observability off the shelf or make a few mouse clicks and get it. It's really something that you've got to build into your processes, into the way the organization works. Of course, tools can help support that in a lot of ways. But it's not a thing that you should think about just getting in one go. It's going to be something that you're going to have to invest in. But what is it maybe? Well, there's a lot of different definitions, kind of going back to control theory. There's folks that talk about unknown unknowns. To me, the most succinct version of this, the way that you have observability, is that you have the ability to navigate from effect back to the cause. If you can do that, if you can see how to go from a bunch of complaining users to a bump in latency, back to the deployment that caused that, back to a bug that was introduced last week, then you've got observability. And that's how kind of think about a sort of yardstick for measuring progress in that investment. One of the questions that comes up is how does observability differ from monitoring? And I feel like we're kind of splitting hairs a little bit on this. I think when I think about what's important, and why maybe we use a new term, monitoring, I think, made a lot of sense. You think about monitoring, you're watching for things. You've established what the list of things that could go wrong are, and you're waiting for them to happen. And that sounds a little bit dark, I guess, in some ways, but that's sort of what dashboards that people do, right? You've looked at all of the possible causes, you've figured out how to determine whether or not they're happening, and then you've built a dashboard for that. And what's happened with distributed systems, with applications built on Kubernetes, is there's just too many failure modes in modern software to just build a dashboard that can possibly show you all those things. In fact, I think there's actually a lot of risk in even trying to do that, because what I've seen is that someone will be on call, something will be going wrong, they'll bring up a dashboard, they'll start looking, and nothing in the dashboard explains what's going on. And that developer or engineer might think to themselves, well, some pretty smart people came up with this dashboard, right? So if the dashboard can't explain it, that means maybe those smart people can't explain what's going on either. So, maybe it's just a network glitch. And that the idea somehow that we even can enumerate all the causes kind of as humans involved is a little bit dangerous, because it sort of leads, I think, to this idea that maybe you shouldn't even try to understand what's going on. where did that explosion, where did all these failure modes come from? Well, as you've distributed a system, you've created opportunities for more failures, right? So kind of thinking about that diagram, the pyramid that I drew, that any failure in that whole pyramid could have an effect on the top. And it's not just a linear increase, right? It's that these interconnections between them and the fan out that you sort of see in these systems, that it's not just the depth of, a depth of say 5 means you've got 5 more chances to fail. A depth of 5 means maybe you've got 25 more chances to fail, or even more, right? There's a lot of things you should think about, maybe that you want to think about when building a dashboard. And I guess what I want to encourage you to think about is like, where's the source of the data for that dashboard? Let's like go one step earlier. Before we start talking about building a dashboard, let's think about the data. Let's think about the application logs and metric. Let's think about the infrastructure metrics. Think about the metrics that are coming from Kubernetes itself. Think about how you're using resources, not just sort of, CPU, but like think about database utilization, think about queue size, think about lock contention, things like that. And think about how we can frame this all in terms of requests. So, obviously I've thought a lot about distributed tracing and how distributed tracing can kind of put things in the context of what the end user is really seeing, right? So even if you're a backend engineer, you still need to be care about what that end user is seeing. So how does observability help? Well, really, it's the approach is providing this sort of comprehensive, a holistic approach to things. You're not just looking at understanding the individual pieces anymore, but how they're fitting together. And that's kind of going back to this control and the interdependencies between these things. It's great that we've given teams the ability to develop and to deploy independently. But if you think about, what the user's experiencing, all those divisions don't make any difference, right? Like they don't care that you're running on Kubernetes. They don't care that you've got 75 services. What they care about is the performance they're seeing. And so observability is really trying to take the view of understanding the system and raising it to this level where we're thinking holistically about it. And like I said, it's not just a single tool or a single dashboard that you can add. It's really thinking about the overall process, thinking about the data, and I'll talk a bit more about this in a few minutes. First, what I wanted to do though is try to just quantify some of the costs that we have here. This is, I'm going to this is a kind of overly concrete example in a lot of ways, but I just wanted to do something specific, and you'll kind of have to scale this out for your organization to try and figure out how it works for you. Okay, so let's just talk about what it costs to monitor a system. And you can think of this either what you're paying a vendor or what you're spending on infrastructure if you're using a solution that you're deploying in-house. Either way, like, maybe you don't see exactly the vendor's costs, you just know what they're charging you, but I mean, take it from someone who runs an observability business, what they're charging you has a lot to do with their costs, right? And I want to divide the costs kind of into 2 categories. So I've got capital costs, and those are sort of what's required to collect and store the raw data, the telemetry. You can kind of think of that as like gathering the raw material. And the other half is the operational costs that are required for actually deriving value, driving business value from that data, from that raw material. And I think we kicked all the finance people out because I'm sure that they're all yelling at me right now because, CapEx is supposed to be about, warehouses and data centers, and nobody does that anymore. But anyway, just think about raw material driving value from that raw material. Okay, so capital costs. Just to kind of make, like I said, a concrete example, let's assume that we're going the open source route. So we're going to deploy like an elk stack or something like that. We want to aggregate a bunch of logs. We want to think about how to index those as well. We're going to obviously need to think about like what our peak instance count is, how long we're going to store that data, sort of the complexity of our system overall, like how many different services are participating in a request. So, just to like, back of the envelope, I'm going to assume 50 gigabytes of log data a day, 14 days retention, and no cold storage. We're just going to keep this simple. Kind of work that out. We're looking at sort of, 1 instance as a master, 2 instances to manage the data, and probably these 3 SSDs, just to actually store it. And if you price that out, at least, list price or whatever, that works out to be about $700 a month. if you were to deploy this on a cloud vendor. Not so bad, maybe, kind of given the scope of things and maybe with respect to the rest of your application. It's probably a lot bigger than this. But these systems don't just install themselves, right? It's not just like you snap your fingers and you've got a logging system. You've got to invest in and continue to invest in maintaining those, right? There's upgrades, there's patches to apply, and those things don't happen by themselves. And so, even once you've got that set up, there's an ongoing maintenance fee, and that comes out to a little over $3,000 a month. So again, the human capital here is pretty significant, and this really is about the engineering time that's required to apply those patches, debug issues, tune that performance as things change over time. Okay, so that's capital costs. We've got the data now, right? We're not doing anything yet, but like we've got it. It's there if we need it. So what do we do with it? So okay. I'm just gonna think about sort of two use cases for that. There's lots more, obviously. But if we think about disruptions and outages in your service as one, and we think about deployments as another, these are two times when folks might go look at monitoring or at logging or at your observability system. So to figure out sort of what it's going to cost to derive the value from that data, we're going to have to think about, what does it cost to employ an engineer? How much time do they work? How many disruptions are they going to have to investigate each year? How long do those investigations take? And so on, how many deployments we have, how long does it take to kind of follow those through, things like that. So, we are assuming on average, an engineer costs about $200,000 a year. That's salary, benefits, payroll taxes, a laptop, whatever other sorts of stuff they need. And, if we assume, they're working sort of, full time, that comes out to an hourly cost of about $89. And we're going to assume that we have 10 disruptions a year, probably a little bit on the low side. I don't have to maybe run a really tight ship and you can keep it down, but like, we're all moving fast and it's fine. We've got an error budget, right? So, so disruptions are going to happen, but assume there's about 4 hours average per disruption. I'm not talking like complete outage, but something comes up where someone's going to have to spend some time investigating. And then, we're assuming each developer does one deployment roughly a week. Again, maybe you move faster than that. We try to move a lot faster than that at Lightstep, which is great, I think. I'd love to encourage developers to deploy frequently. But each one of those comes with some cost, right? There's a little bit of validation. That's a tense moment for a developer, right? That's when the rubber hits the road, right? And they see whether or not their code is actually really truly going to work for your users. So, okay, so how do we kind of plug all these numbers in? What do we get? So about $3,500 per disruption. So kind of digging into this a little bit, like we're sort of assuming 10 developers get pulled in one way or another. There's about 4 hours going on here. And maybe 10 seems like a lot to you. But remember, this is not just like how many people were necessary in a true sense of like who had the knowledge and who had the means to fix the problem, but all the people that got pulled in, whether or not they were actually required or not, right? I think I talk about, I hear people talk about mean time to innocence instead of mean time to resolution as an important metric. MTTI is really, as an owner for, say, service A, how long in the middle of an outage does it take me to verify that it's not my fault and that I can go back to sleep or I can go back to the rest of my work? And that's where we kind of come up with 10, because it turns out that, when you're in the middle of an outage, you ask a lot of people what's going on. You're not sure, and it's better to ask a question if you're not sure than just to kind of sit on it, because that's just extending the length of the outage, right? So maybe not huge. Deployments, on the other hand, can really be a significant thing, and I think this is a little bit of like a 1,000 cuts kind of situation. So, again, we want to encourage developers to deploy often. That's how we get things out there. We make each one of those deployments lower risk. Maybe that's how we got down to 10 disruptions. But there's a lot of time that each of those engineers is just sitting and looking at a dashboard, looking at some metrics, trying to understand what's going on. And for a team of, say, 60, we're talking about $130,000 a year. That's almost another engineer, right? That's pretty significant in terms of thinking about your headcount, thinking about how your team is spending their time. And so I guess, how do we fix this, right? We can't necessarily just like, turn down the dial on the number of disruptions, right? And we don't want to turn down the dial on the number of deployments. Those are important. That's how we're delivering value, right? But the thing that all of these have in common is time, right? So, you can't control the number of instances. You can't make a CPU run faster, but you can control how long it takes to perform the sorts of tasks that I was describing and the number of engineers that are involved. And what we've found at Lightstep, in working with our customers and talking with others in the community, is that an effective observability practice that is as part of a transformation from not just a monolith to a microservice-based application, but from a traditional monitoring perspective to an observability practice, that transition can have a really big impact on these numbers. So what does that look like? Well, we've actually found that it can have as much as a factor of 5. So, instead of $3,500, we're talking about $700. Instead of $133,000 a year, we're talking about $26,000. And that's really just because, in the case of a disruption, fewer people have to get pulled in. We understand more narrowly where the problem is. We can find the right person. We can find that person more quickly, right? We don't have to dig through a bunch of Slack. We don't have to go through a bunch of code to understand who you might be able to help. Like, we've got that at our fingertips. We can get that person on the on chat. We can get that person in the room, and we can fix the problem. Now, on the deployment side, we can just reduce the amount of time it takes to validate a deployment, like build that confidence with engineers that everything's fine and it's working. And if it's not, that they'll be able to see that within seconds or minutes, and not 10, 20, or 30 minutes later. So again, if we can reduce the amount of time, we can really reduce the cost of these things. Okay, so how, great, how do I get that, right? And really, this is going to be about this practice of holistic observability. And the key to that is really using context to control those costs. And that context is, you create that context in 2 ways, which I'm going to talk about next. So the first one of those is really about the communication. How do we build a shared language to discuss performance? Doing that through things like service level objectives, SLOs, and service level indicators, SLIs. We at Google, we found that this kind of observability practice was critical in just eliminating finger pointing. We would have cases where an infrastructure team, maybe a team that's managing storage on one hand, and an application team like Gmail or something would just be sitting in these long meetings saying, we're using the API correctly. No, you're not. Well, your API is too slow. No, it's not. And they each had their own set of metrics to try and understand that, and really kind of trying to bring back a holistic view of what's going on was critical to say, like, look, we're all just going to look at the same data, and then there's not going to be any subjectivity to it, right? We're all just agreeing on what's happening, and we can move on from there. Putting just a kind of, if you're not familiar with SLOs, SLIs, go read that chapter from the Google SRE book. And I'm not saying you have to adopt every practice in that book, but I think if you're going to pick anything, SLOs are about taking engineering measurements and putting them in the context of your business, right? So I hear a lot of people talk about MTTR as like a thing that they want to optimize, and I don't know. I mean, do your users care about MTTR? Like, it's a great, don't get me wrong, it's like a great metric to think about how your engineering teams are working. But in terms of the business impact, like, it's really got to be about whether or not you're meeting your SLOs, right? Because that's what you've claimed that your users are demanding. That's what you've promised your users, and you got to measure yourself to those promises, right? Observability also helps avoid alarm fatigue. Again, this is, you can have lots of different kinds of alerts. We should be alerting not on root causes, but alerting on symptoms. I think this is especially and more true now than it ever has been before, just as the number of possible root causes has increased so much. And by really focusing on the things that matter, you're going to help your operations team. You're going to help your service owners really focus on things that matter. Because honestly, in a complicated distributed system, there's always things that are broken, right? That's just how engineering works. But whether or not those broken things are actually affecting your users, that's really the important question. Because if they're not, like, throw it in the backlog and deal with it later. Anyway, this kind of overarching here. This is all about creating the shared language, creating a shared context for communicating, so that as an organization, we're working on the right things, and when something does go wrong, we can all make sure that we're speaking the same language, and looking at the same data. Speaking of data, the other way that observability brings context is by combining these multiple data sources. So one of the other ways that folks talk about observability is the three pillars. The three pillars being logs, metrics, and distributed tracing. And that was a way that it was successful at Twitter and moderately successful at Google, at least speaking from my experience there. But the issue was really like, we found with Dapper, when Dapper was isolated, when it wasn't like the user interface wasn't combined with the other user interfaces that our users, our engineers were already using, no one noticed it. No one used it, right? We had to really put it and integrate it with the workflows that were already there, integrate it with the data that they were already using, so that they could see it at the appropriate time, right? So again, I don't really think of the three pillars. Like I strongly recommend against like thinking of the way to get observability is by buying three tools, because it's going to be a long uphill road to try and get people to use all of those. And secondly, I think you're missing out on a lot of opportunity where those things can really reinforce each other. So logging can be really expensive, but you can use tracing to tell you which logs are most important. So don't store all the logs. Most of them are boring, right? Store the ones that actually help you understand requests that have errors, requests that are slow. Similarly for metrics, right? If we can put metrics in context, is this metric actually part of a request that matters in some way? Great, store it, keep it, pay for that cardinality. But if it's not, like, let's think twice about that. And this, like I said, this really helps from an efficiency point of view on two sides. One on the, as I said, the operational side, like saving time, making sure we're putting the right data in front of your team and your teams at the right time. And then from a data storage and data management point of view, using that context to actually select for and understand what data is actually worth collecting and what data is actually worth storing. Because there's a lot of data, and I don't want you to have to feel like the solution is just to log less, right? Or like, we're just going to turn off logging in QA. Like, someone turned it on for a reason, right? That was valuable. That helped them understand what was happening. And I think the other part of this, just to maybe try to bend your minds a little bit, like logs, metrics, and traces are really three data structures. They're not fundamentally that different, right? So you can take traces and derive metrics from them, right? Traces contain all kinds of numeric data. You can build time series out of those things. You can take logs and make traces out of those things, right? Like if you have a correlation ID within a log, you can take that and you can build a trace from those pieces. And you can think of how you can combine these things in other ways, right? So again, of course, from a data structures, from efficiency engineering point of view, yep, we should definitely consider how these things are different. But bring it back to what we use them for and how they get used. Really kind of think about how we can bring that all together and take a holistic approach to that. Okay, so that's how it helps. How do you actually get it? Let me talk a little bit about how to implement observability. And this will kind of be wrapping up my presentation for today. So first part is make sure that your services are observable. I'll talk a little bit about that. Second part is to focus on the key SLIs and make sure that your SLOs focus on business goals. And third, maybe there's not too much of a surprise given the things I said about your organization, about your engineers, about your developers. Put people at the center of your strategy, because looking back at some of those costs, whether or not you're talking about getting the data or deriving value from the data, a huge portion of those costs are about the time that it takes people and the number of people that are involved. So think about those people when you're optimizing. Okay, so how do you make your services observable? So I'm going to flat out recommend OpenTelemetry is the way to do that. OpenTelemetry is a CNCF, Cloud Native Computing Foundation project, and it's a whole collection of tools for integrating your application with different observability solutions. So you can think of it, there's an SDK, it's multi-language, it's a way to actually connect your application, it's a way to connect open source projects with those observability solutions. There's also a bunch of other tools for managing, collecting some of that data. And I think beyond OpenTelemetry, think about how to integrate observability into your abstraction, into the platform. So sure, your infrastructure team's providing Kubernetes as part of that platform. Think about how to complement that with an observability solution, maybe with something like Istio, right? Istio or other service meshes are a great way to collect a lot of data in a uniform way from the application that's really low effort for the application developers. Yeah, if you want to know more, check out opentelemetry.io. Okay, number 2, creating effective SLOs. This is really about standardizing, again, making sure you've got this common language. My recommendation, focus on the golden signals, things like latency, throughput, and errors, at least if you're talking about a user-facing service. For batch processing, maybe things like the overall throughput maybe are more important than something like latency. But these are, great because they sort of, I think, do a really nice job of bridging between how the software is behaving. Latency is something that's easy to measure. It's easy for an engineer to understand, but it's also easy for a product manager to understand. We can easily quantify the effect of latency. Folks have done this. Google's done this. Amazon's done this. Understanding how even hundreds of milliseconds of latency can have huge effects on conversion rates, checkout rates, on interaction engagement from users. And this is really, we can talk about nines and uptime and things like that, but really it should come back to something like, when people try to play a song, it plays, right? That's what your users are going to complain about. That's what you've promised them. And so make sure your SLOs line up with what those promises are. And then, like I said, people are a really key part of this. So, using observability, the insights from that, the data from that as a component of your retrospective, of operational review. Lightstep's been used really effectively as sort of the tool that we all gather around to look at when we're trying to understand what happened in a postmortem. And it's part of sprint planning, right? Like at Google, teams used to go off and, optimize the heck out of their service, and it turned out that like their service wasn't on the critical path, so it didn't matter, right? Making sure that we really understand how the effect of an engineer's work is gonna propagate, up the stack and ultimately impact an end user is really important, even at the level of sprint planning. And while Kubernetes increases complexity in a lot of ways, right? We're raising the abstraction, so there's more going on underneath the hood. Observability is a nice way of complementing that, right? And it can make that abstraction more accessible to people, even if they're not experts. And you can see the impacts of changes that that your teammates, that other teams are making. And so thinking about, like, of course, tools like Kubernetes are supposed to make things easier, but and observability lets you see what's going on, right? So thinking about how that technology is affecting your team, I think, is really important. Observability is a way to kind of understand that as well. So again, thinking about building for observability from the beginning, check out OpenTelemetry. Thinking about how to map those promises you've made to users into things you can measure, and thinking about the people that are involved. Okay. Before we get to questions, I just want to leave everyone with one other thing. I mentioned Lightstep a bunch. If you want to hear more about that, go.lightstep.com/request-a-demo. You can get help from someone. We've got a ton of people that have thought about this a lot. We've got some sandboxes you can play with, a lot of good stuff. So yeah, with that, thanks everyone. And see what kinds of questions you have.
Well, all right. So I'm not sure whether I love or hate the mean time to innocence, but I love that. Okay, so we have about 20 minutes for some questions. I've got a few here that I'm going to ask. But again, if you look in your user interface, there is a question dialog. So just drop some questions in there. And while you're doing that, I guess I'm going to launch in and ask a few things. So I guess the first question that I have is around log metrics and tracing, right? So I really liked, I wrote it down, navigate from effect back to cause. I really, really, really like that. How do you, I guess, come to terms with that when you have to do things like sample, when you have to do things like aggregate? How do you kind of, I guess, kind of come to terms with that tension?
Yeah, so why are we sampling to begin with, right?
Yeah.
I think, right, I mean, that's, I guess, my first question, right? And I think that's just because there's a lot of data, right? And
Yeah.
like I was saying, a lot of the data is pretty boring, hopefully anyway, right? Hopefully most of the
Mhm.
time everything's fine. So to me, sampling is really about how do we, sampling and other forms of aggregation, the goal here is about reducing the amount of data.
Right.
We found it at Google, we could leave Dapper on all the time in production. And even if we were only actually doing the recording, I think we had to get up to like 1 in 16 or something like that. Like 1 in 16 requests had to have measurements before anyone could even measure the impact on performance of the app itself. But the amount of data that generated was so huge that we had to
Yeah.
throw out like 99.9% of it because the network and storage costs with it were too high. So it's really like, it's another part of this whole cost question. So, okay, we need to sample and we need to aggregate. How do we do that? And to me, that's really thinking about what are the SLOs, what are the things that you're trying to measure, and then making sure that you've got the data to back that up. So one thing at Lightstep that we did differently than at Google is like, it's like kind of from a um, surface area point of view, it's pretty boring, right? It's like there's
Yeah.
a text box, you put text in, you get some results back. No one even knows if those are the right results, right? Like there's no correctness condition. So like this idea of just like totally uniform sampling is fine because the requests are actually also totally uniform.
Mm.
But if you're trying to do things like, debug an error that's only showing up in a 1% experiment in Europe from users that are in your premium tier, then throwing out 99.99% of the data is actually pretty bad. And so being able to sample and bias that sample towards the higher value information is pretty important, I think. So again, thinking like, where are the slow requests? Cool, like let's grab some of those because those are going to be those are going to have the actionable insights, right? Anyway, I don't know. I feel like I could talk about sampling for hours and hours and hours. So
Yeah, sure, sure. You talked a little bit there, and then in your presentation you also talked about like kind of golden signals, latency, throughput, errors. What are some of the really other high value things that really make a lot of sense to capture?
yeah, so
And I
those I
fully
think are,
recognize that's based on your SLOs and it really
yeah.
understanding that.
Yeah, well, I mean, I think so. Okay, you're running, an e-commerce app, right? So your SLOs are about, um, you know,
Clicks and
latency, render
bar.
time, things like that. Cool. Yeah. What else should you measure? Well, like, what would explain what's going wrong, right? So, measuring, obviously, the calls between services is really important because that's a failure point, right? Measuring things like queue size, timeout rates, even, associating like tags around things like what tier a customer's in, what segment they're in. Like all that data is really important, and so measuring it is really key. Measuring, database load, things like that. It's just like from an alerting point of view, you don't want to wake someone up in the middle of the night because your database is slow. I mean, you only want to do that if it's actually affecting users, right? And so I think thinking about, of course, measuring things like SLOs, SLIs, and how you're going to use those to alert your team and take action. But then all of the tens of thousands of signals underneath the hood that might explain what's happening are also really important.
Yeah. So Ramesh asked a question about data granularity. So he talks about the diminishing value over time. So is there a way, a mental model that you kind of suggest for downsampling and storing for the longer term?
Yeah, good question. So the first part, I guess I would say, um, let's see. So the initial granularity, I guess when the first part of the question, the thing I had in my mind is like, how much logging to do or how many spans to create, span being kind of the small piece of a
Yep.
trace.
Yep.
And that kind of gets back to like where failures can occur, right? So having a span or having a log statement sort of around a potential failure so that you can measure when that failure is occurring or when it's not occurring.
Mhm.
In terms of things like downsampling, I would say, if you're doing downsampling correctly, like if you're doing it in a way where you understand the relationship between the sample, the small piece, and the big piece, then there's a lot of opportunities for that, right? So, like, one of the things that's nice about uniform sampling is you can sort of just multiply everything back by 10,000, and now you understand how fast things are happening. So I guess one key part, no matter how you do it, understand that you're recording how you do it so that you can undo it in effect. I think the other part of this is just to look at where the key events have occurred. When have you done deployments? Like, keep that around. When do you have, what's your seasonality? Like, do you have, strong weekly patterns? Like, well, definitely keep data for a couple of weeks. But maybe, after a couple of weeks, keeping it at a minute by minute level isn't so important anymore. And doing some further downsampling can be totally fine then.
Mesha asked a question that you kind of touched a little bit on it when you talked a bit about like with your logs, you can drop a correlation ID and be able to recompose a trace from just logging. So his question is really around what's the difference between a log line and I guess a trace line that you're capturing.
Yeah, that's a great question. I mean, at some level, tracing is like a special kind of logging. It's just, in my opinion anyway, really special. So,
Might be
you know,
biased.
yeah. So, I mean, so again, like the unit of a trace is sort of a span, which is really, it's actually closer to a timed event than just a log. Usually with a trace, we want to record not just the moment in time, but the duration of time, the beginning and the end. So at some level, which should you choose one over the other? I would say think of them as data structures. Think of the trace as the skeleton. And then logs can kind of fill in some of the details on that, but use tracing to create the right kind of skeleton so that you understand the structure of your application.
I like that as data structures. I think that made a lot of sense when you said that in your talk. Ramesh asked another question about it seems like we're still relying quite a bit on humans to be able to analyze and diagnose and into you talked about mean time to innocence. How many people, how many engineers get involved with trying to discover what's going on? That's where the cost lies. He wants to know, are we seeing any advances with ML, AI, anything to help us be able to remove the human in the loop, I guess, here?
Yeah, it's tricky, I think. I feel like I've talked to a lot of, especially investors, they love to talk about ML. And the thing about when you apply machine learning to like, spam or like ad clicks or something like that, like you don't really care about the why part. You're just like, is it correctly classifying spam or not?
Yeah,
But when you're talking about a distributed system, like the why is super important, right? So having like visibility into the models is really important. The other thing that makes it hard is that these systems are changing. Like email, of course, changes over time. Spammers make new techniques, I know. But like the way your software is like totally different from an algorithm's point of view than it was 1 month, 2 months, 6 months ago, right? And so that, like a model that you built 6 months ago would still make sense. I think it's pretty tough. That said, I think there are some opportunities. Like I said, there's tens of thousands of things that could go wrong. Just doing some analysis of that data we've found to be super effective. So sure, like we just noticed a deployment happened. Let's go grab a bunch of data and we can just do a regression test, right? Like we have before and after. What kinds of metrics, what kinds of logs even changed between the before and after? And that those, if you can whittle that 10,000 signals down to 5, now you've brought it down to human sort of scale.
yeah.
And so I guess I think of the real benefit today of ML and of an algorithmic approach is really about putting the right data in front of a human so that they can make the right choices.
So Mariko asks a question that I actually had down on my list too, and it's kind of around alert fatigue, identifying patterns, understanding. I mean, just obviously, if you've carried a pager, yeah, pager duty. My partner up there just flinches if she hears pager duty, no matter when it is. Just the word, and she's not in software. So, how do you identify patterns to be able to kind of dial down and reduce the alert fatigue? Any suggestions? It's pretty open-ended, but
Yeah, I think to me it's about giving teams both the authority and the tools to make changes, right? Like they are strong, like if you're strongly incentivized to fix it, right? As
yeah.
long as you have the authority to do that and you have the knowledge to do that, right? So to me, this is about making sure, one, that as an organization, you're lining up alerts with the right owners, and that those folks have the right information at hand so that they feel confident that they can either fix the problem or, totally reasonable, delete the alert, right? That's
Yeah,
definitely something that we practice, right?
totally. And we have a question from Charles Humble. So this question is around kind of open telemetry versus things like Zipkin, Dropwizard, Micrometer. Can you talk a bit about like what's the sweet spot? What's the things you got to think about? What are the trade-offs? What are the challenges? What, just talk a bit about it.
Yeah. So that's a great question. So yeah, instrumentation, like getting the data, is a really interesting problem. So OpenTelemetry is really about, it's kind of like it's like building a community from the technical standards and from the APIs. The history of this kind of goes back as like when we started Lightstep, there were, Zipkin was out there. There were some other tools that folks were using, and we kind of we were talking, this tracing community is not huge, surprising. We were talking with other tracing folks, and it turns out we all had basically the same API, but we
Yep.
spelled it differently, right? And that was a real obstacle to people adopting things, right? Like there was an Apache Foundation project that basically just threw up their hands because they said, we think having to make a choice tells us that this is not ready for us. And so OpenTelemetry is really about not making that choice, and about making it in a vendor neutral way. So you can, there's a Dropwizard integration for OpenTelemetry. So you can get data out of your application that uses Dropwizard right into OpenTelemetry without changing your application at all. You can use Zipkin, there's a little bit of adapter going on, but you can use solutions like Zipkin with OpenTelemetry as the back end for what actually happens in terms of the analysis. So think of OpenTelemetry as like choosing the pipes and giving you the flexibility to hook different kinds of analysis engines on the back, even multiple analysis engines. And because those are going to change, your needs are going to change, but connecting the pipes is a bunch of work. And so think about OpenTelemetry as a way to like maximize that investment, a return on that investment. Sorry.
So I've got this question, and it's wrapped around this phrase of some assembly required. A lot of people kind of think, I've heard a lot of engineers say, I still have all these problems. I have these great tools, but I still have all these problems. Can you talk a bit about what's still left? You may get great tools. You may want to use open tracing. You may use Lightstep, but really, what's the assembly required for an engineer to be able to get up and be able to reduce that mean time to innocence?
Yeah, so I think it depends on platform. Like if you're talking about Java or Python, things are a lot easier. If you're talking about Go, just by its nature, Go makes things a little bit harder. And it also depends on like what frameworks you've used. Like the open tracing, open telemetry communities have tried really hard to provide integrations with frameworks that others use, but we can't do all of them right away. So I think though that it can be pretty quick, even for an individual service. And the way that I would think of sort of my advice to folks when they start, sort of no matter how big their organization is pick one thing in the middle, and think about tracing and observability as a way of mapping between inputs and outputs, right? So you can measure sort of the service you're providing to whatever's up the stack from you, and you can measure at the same time whatever's below you on the stack, and you want to be able to connect those two pieces. Because talking about mean time to innocence, the thing you want to be able to do is when someone from another team comes to you and says, hey, I think your service is slowing us down, I'm going to need you to roll back, or like I think your service is our problem, like I need you to like go figure it out. If you can quickly say, no, actually, I looked at our P99 requests and those are all slow because of this other service over here, go talk to them and then go back to bed, right?
Yeah.
So I think really focusing on the connections and the relationships is a way to get like maximum value quickly. And it doesn't take like a super deep integration, right? You're using a framework for answering those requests. Maybe you're even using the same framework for making requests, right? So a gRPC interceptor, a Dropwizard configuration change. There's easy ways to do that and start getting something going quickly.
So there's another question here on SLIs and SLOs. Can you revisit them? The question is kind of what is really the main source for defining an SLO, and can SLIs be defined based on monitored performance metrics? So really, it's just a question around SLOs and SLIs.
Yeah. think, I play an SRE on TV. I think if I would do that, there's a question about stakeholders here, right? So
Yeah,
getting someone from the product side involved, getting someone from the development side involved, getting someone from the operations side involved, and making sure that you can get agreement among those folks about what you're going to measure. That's at some level, if it doesn't really matter if you can get those three folks to agree, right? And then from there, once you've got the indicator defined, start measuring it, and then figure out like what your budget is, right? Don't
yeah.
set your P99 latency goal to 100 milliseconds if your average is at 200 milliseconds, but measure it and then go from there.
Sounds good. All right, we are at time. Spoons, thank you so much for taking the time to walk us through this. Obviously, an immensely important topic that I've had alert fatigue, and I've definitely had had some of the sleepless nights. So, getting better with observability, getting better with how we think about observability is core to being able to operate things like Kubernetes well and our microservice environment. So, thank you for taking the time to run through it. Thank
Yeah,
you all for joining us, and we will have new ones coming up. Watch your inbox, watch InfoQ, and look for the next set of webinars from InfoQ. Spoons, everyone else, thank you for joining us.